Hello and welcome back to Mrs. O'Graham's Maths. This is a worked solution video for a practice paper that was used in 2023 by my school, going through a integration parallel paper to the external. So it's not one of the NZQA past papers, but it is written very much in a similar style to them. So useful revision and extra practice. So I recommend that you pause at the start of each question, have a go at the question because it'll be brand new to you, not from a past paper, but from a parallel paper, and then play along with the worked solution and see if you were able to get it. So we are integrating on question 1a here. We're integrating x over 2 and 2 over x. So those are two separate terms. We'll integrate them each individually. So the x over 2, we raise the x to by 1 power, so it's going to become x squared, and then divide by the new power of 2. So we've already got a divide by 2, so dividing by another 2 will be 4. And then 2 over x, you bring the 2 out and it becomes 2 times 1 over x. You can do that with integration. You can take constants out. So that will be 2 times the integral of 1 over x, and that's on your formula sheet. So 1 over x integrates to log x. And then, of course, finish with a plus c. For part B, we've got a gradient function is equal to this, and we want to find the equation of the function. We've also got some information of a point that it goes through. So we need to integrate this to work out y. So from there, if we can turn this into something in power form, it makes it, well, I find that it makes it easier to integrate once it's in this form. So we'll raise the power by 1 and divide by the new power. So raising the power by 1 minus a half plus 1 gives us a half. And then if we divide through by the new power, dividing by a half is the same as timesing by 2, so it cancels out the 2 that was there. And then you have the plus c. Now for this one, we're going to work out the value of that c because we can substitute in the values of 4 and 11. So when x is 4, y is 11. So we substitute that in and work out that that means that c must be 1. So we can write our y equation with the c correctly filled in just here. For part C, we've been given some information here. This integral is equal to k, and we need to work out the value of k. We're told k is more than 5. That's not super relevant. It just means k is a bigger number than 5, so we know that that integral is the right way around. Okay, now first of all, to integrate this function, we need to do a bit of algebraic manipulation. I'm going to use a method that I refer to on my previous videos as algebraic juggling. You could also do long division or however else you want to sort that thing out. So if we take a look at this being all over x minus 4, I'm first of all going to rewrite the top in terms of a multiple of x minus 4. So if that x at the top there had a number in front of it, I would times this bracket by that, but it doesn't. It's just got a singular x. So start with x minus 4. Now to make that match here, we need to add on another 2. So that top line is now equivalent to this, but it's written where part of it has the x minus 4 in it. And then we will integrate that thing. Now the reason we do that is because we can then separate out this fraction into its two pieces. So this first piece here, x minus 4 over x minus 4 is 1, and plus 2 over x minus 4, that gives us this bit here. And both of those things we can integrate. So if we integrate 1, we get x. If we integrate 2 over x minus 4, that's 2 times 1 over x minus 4, and 1 over x minus 4 integrates to log of x minus 4. Now we're putting in values here. We're doing a definite integral. We're integrating this between 5 and k. So let's work out what that would look like. So we substitute in k. So k is going in place of all the x's here. And then we take away the substitution of putting 5 in there. So 5 going in place of where all the x's are. Now back to the question. We're told that that is equal to k. Now we're going to go through and solve. So the k's cancel each other out. We're left with 2 log k minus 4 is equal to 5. If you put this into your calculator, you'll see that that's a 0. Log 1 is 0. So then rearranging that, we get log of k minus 4 is equal to 2.5. And to undo the natural log, we raise things to the power of e. So that'll be k minus 4 is equal to e to the 2.5. Therefore, k is equal to e to the 2.5 plus 4. Now you could work that out on your calculator and give a decimal, but I'm only going to go as far as that because this is a more complete answer to me because it's not giving any rounding. Okay, pause and read the question, and then I'm going to plow straight in. So we will start by, to be able to find the shaded area, we need to know what these intersection points are so we can work between them. So first of all, we need to set those two things equal to each other. So we've got x plus 4 over x is the equation of the curve. We're going to set it equal to 5. And then we continue on to solve this. So multiply through by x, rearrange it so that it's all equal to 0, and we have ourselves a quadratic which factorizes quite nicely, and so we have the solutions of 1 and 4. So that goes back onto our graph like this. So we're finding this area between 1 and 4. Now to find that area we need to integrate. If we were to integrate simply the curve between 1 and 4, we'd find this area underneath rather than this area between. So we need to integrate the line minus the curve. So we'll have the area that comes under the line and we'll subtract the area under the curve, and we can do that all in one step by writing it as one equation. So we do the equation of this line is 5, and we'll take away the equation of the curve and we'll integrate between 1 and 4. So that's what that looks like, as 5 take away the equation of the curve right here. Now if we integrate each of those pieces, we get 5 becomes 5x, x becomes x squared over 2, 4 over x is 4 log x. And we're going to integrate that between 1 and 4. So substituting in 4 looks like this. Then we take away the substitution of 1 in there, and we start to simplify it down. So we end up with either leaving it in exact form like this, or write that as a rounded decimal of 1.95. And now for the excellence question. So we have a curve that we're told that the gradient on that curve is proportional to this. So let's first of all write that down. Now you need to just know how to write proportionality down. So it looks like this, where we're saying the gradient is proportional to means that we write equals k times, or some other constant times, it doesn't have to be k, but we usually use k, the thing that it is proportional to. So there's the thing it's proportional to. So these two things are proportional, so we write them equals, and then we have a constant in there of k. Now we are going to try and solve this, and that involves separating variables. So bring the y to one side, so this e to the y becomes e to the minus y, or 1 over e to the y if you prefer. And the x's, all I've done here is I've taken the dx up to the right hand side, leaving the k on that side, and now we're going to integrate both of those sides. So if we integrate e to the minus y, we get minus e to the minus y, and the right hand side integrates like this, remembering k is just a constant, and that's used the chain rule to integrate this feature just here. And then finish it off with a plus c. Now we're going to use the values that were given to us in the question to work out the value of c. So when x is 0 from this point here, we know that y is also 0. So we can put y0 in there and an x0 in here. And that helps us to work out the value of c in terms of k. So c is equal to minus 1 minus 8k. Okay, next we'll substitute in these values here. So when x is minus 12, y is log 9. So when x is minus 12, we can put in that y is negative log 9. And so then also substituting minus 12 in place of the x here. So I'm just taking this line here again and substituting in the values, but now we know that c is minus 1 minus 8k. Okay, so working that through, e's cancel each other out, so this becomes minus, okay, so this might just take a little explaining, minus 1/9. So minus log of 9 is the same as log of 9 to the minus 1. That's just using log laws. So that is log of 1/9. And so minus e times by log of 1/9 would give us minus 1/9. Or just put it in your calculator and it will work that out for you. Okay, so then working this through, you get to be on this line here, 4k minus 1 minus 8k. Okay, and taking that through, then we get 8/9 is equal to minus 4k, so k is equal to negative 2/9. So then the final stages of this one is to take this equation that we had here, substitute in the c and substitute in the k, and then use it to work out the value of y when x is minus 7. Okay, so let's go ahead and do that. Right, so we have, here's our equation. We've substituted in the values of k and c for what we know them to be now. And we're going to work out, I've just rewritten that to simplify it. We're going to work out when x is minus 7, what this gives us. So popping in those values looks like this. Working it through, we get e to the minus 9 is 5/9. And so solving that, y is the negative log of 5/9, which is 0.588. Okay, back to some of the easy stuff. 2a, achieved question. We're first of all going to write that into power form to make it easier to integrate. Then integrate each term. You know how to integrate e and x with powers and then add on your plus c. Part B is using Simpson's rule, which looks like this. So we just need to take the pieces from that table of values and put them into the formula. So here's the empty formula, if you like. Now the h part is the gap between our steps in x. So that's 0.5. Then we pop in the first and the last values. So that's the 1.8 and the 4.9. We do 4 times all of the ones in the odd positions, remembering that this is position 0, so this is position 1, 3, and 5. And then 2 times all of the ones in the even positions. So this is position 2 and position 4 just here. Work out what that is, you get 15.68. For question C, we're on to kinematics. We've been given the equation for acceleration, and we need to get down to displacement. Okay, so we'll need to work through velocity first. So if we integrate acceleration, we get velocity. So the velocity will be this thing integrated. So if we integrate 1, we get t. If we integrate minus sine, we get plus cos. And then, of course, finish with a plus c. Now we need to work out the plus c, which we can do from this information just here. So when the time is 0, the velocity is 2. So set that equal to 2 when t is 0, and we can see that c will be 1. Now we integrate the velocity again to get the displacement, which we call s of t. So if we integrate t, we get t squared over 2. Integrate cos, we get minus sine t. And if we remember that c is a 1, we integrate that, we get t, and then plus a constant. Again, I'm not going to call it c this time just because it's not that c there. I'm going to call it k. And now we need to work out the value of this constant. Again, we use this information up here. So when t is 0, the displacement is 4. So if we substitute in a 0 and set it equal to 4, then we can work out k. So from this line here, all of these are zeros, so k is equal to 4. So now if we want to work out the final answer here, what's the displacement of the object when t is pi? We're putting pi into this equation here, or sorry, rather this equation here, and then working through what that would be. So that comes out to this, which is equal to 12.08 meters. For question D, we need to separate variables. So taking the y over to one side and leaving the x on the right-hand side here means we also need to bring the dx up to the right-hand side. We leave the dy where it is, and then we will integrate both sides. Okay, so integrating y squared, we get y cubed over 3. Integrating sine 3x, we get minus a third cos 3x, and then we have a plus c. And we'll use this information up here to work out the value of c. So when y is 3, we get y cubed over 3 being 27 over 3. And that happens when x is pi by 6. So that's equal to this here with pi by 6 substituted in for x. Obviously, if we times that by 3, it becomes pi by 2. And then plus c. So working that through, we know that c is equal to 9. Now we're asked to work out y when x is pi. So if we put pi into this equation, where we now have the c being the plus 9 we just worked out, then we can follow that through to work out what y is. So that becomes y is the cubed root of 28, or 3.037. Okay, now for an excellence question. Now this one was actually really quite tricky to spot how to start it. So we need the shaded area, which means that we need to work out this integral here. Now that's really hard to see how to integrate it. You have to do a bit of algebraic manipulation to get to a point where you've got things you can integrate. The problem being these powers here, right? We can't do an awful lot with them as they are. So we're trying to sort that out, and you can look at your formula sheet looking for trig rearrangements that you can do. So the first thing is if I take out a sine x, then sine cubed x would have left me with a sine x times a sine squared x. Sine squared I can rewrite as 1 minus cos squared, and then put back in the cos x to the half. Then if I multiply out that bracket, we end up with sine x cos x to the half minus sine x cos to the 5 over 2, just multiplying this through. Now that might not look like it's helped much just yet, but bear with me. What that's done for us is brought sine x out, which is a result of differentiating cos x, right, in both of these, which means that we can look at this as being the result of a chain rule happening on the cos x part. So consider what would happen for that first bit there. If I'd have done, if I'd start with a cos x to the 3 over 2, so it's this cos x here, but 1 added to the power, so a half plus 1 is 3 over 2. That's why I've started there. If I were to differentiate this thing, I would get 3 over 2, and then reduce this power by a half, and then times by the derivative of the inside, which is minus sine x. Okay, so that's really close to this thing here. It gives us the cos x to the half, and it gives us a sine x as part of it. We'll just need to do a little adjustment. Similarly with the other piece, if I add 1 to this power, I get cos to the 7 over 2. If I were to try to differentiate this thing, I've almost got back to where we've got here, just some added numbers. So I've got the cos x to the 5 over 2, and I've got the minus sine x introduced back into there. Okay, so the integral that we had up here, if we compare this to this, then it's negative 3 over 2 too big. So times this by negative 2/3, and that will fix that up. So if you now try to differentiate this thing, it will go back to this thing. Similarly with the other piece, we're going to add on, well, it was a subtraction, but we're going to take this 7 over 2, we need to turn it into a minus 1. So we actually need to times that thing by -2/7. So that's why that minus became a plus. So that's what the integration now looks like, and we're doing it between 0 and pi by 2. So I've done a bit of reverse chain rule on this thing to get to this line. There's a couple of ways you can go about doing that if you're not comfortable with the way that I did this one. You could, for example, use integration by substitution if that's your preferred method. Now substituting in pi by 2 into this, and then take away, substituting in 0 into here. And that gives us 8 over 21, or 0.381. Okay, question 3a. First, rewrite this thing into something that's easier to see what we're doing. So 1 over x plus x, the whole thing's been squared, so I'm multiplying out that bracket. Don't forget the middle term here. So do the full bracket times by itself. And integrating each of those terms looks like that. All right, question B. We're going to integrate this thing. Sec squared integrates to tan. So we are integrating tan 4x. The 4 gets divided by the 4 in here. It's a reverse chain rule. That's why this then becomes 1 tan 4x. And then plus c. Substitute in the values to work out what c is. That's from the question up here. And then work out that means that c is 0. So now when x is a quarter, we can work out that y is equal to tan pi, which is equal to 0. Part C, we're going to integrate this thing. Now, where this question gets confusing is we've got k's involved in here. Now, remember, k is just a constant. It's a number. So when we integrate this thing, we are raising x to the power of 1. So where x was to the power of k, it's now k plus 1. We divide by the new power, and that k plus 1 is still in there from where it was before, because it's just a number, just as if that had been like a 7 at the front. And we would integrate that and put in the limits from 0 to 2. Now you can see that the k plus 1 cancels with k plus 1, and we've just got x to the k plus 1. If we substitute in the values, we end up with 2 to the k plus 1 minus 0 to the k plus 1, or 0 to the power of anything is 0. So this is just 2 to the k plus 1. We're told that that equals 10.8 in the question. So we can work out that k is 2.33, and that one I just did using equation solver. Part D, we're finding this shaded area just here, which means that we need to know when these two things intersect. So set the equation equal to 3, so we can work out what that value is of k that we're going up to. So if we solve that through, we end up with this quadratic, which factorizes to x minus 3 squared equals 0. So k must be 3. This is the solution from here. So x equals 3, therefore the x value at this point of intersection is 3, so k is 3. So now to find the area, we will integrate between 0 and 3 for that curve. Integrating 18x over x squared plus 9, you need to recognize that the top is to do with the derivative of the bottom, and that means we go straight into natural log of the bottom. Now, if we differentiated the bottom, we would get 2x, whereas we actually want 18x, so it's 9 times bigger. That's where the 9 comes from. And so as long as the top is the derivative of the bottom, you then just multiply it by how many times bigger you need it to be. And we're going to do that between 0 and 3. So substituting in 3, we get 9 log 18, and substituting in 0, we get 9 log 9. So that equals 9 log 2, or 6.24. Okay, again, we're working out some area stuff. So we've got the function 4e to the x, and then y equals 4/3. And once again, we need to find a point of intersection. So set them equal to each other, and we get that x is equal to log of 1/3. So this point of intersection is log of 1/3. So now we need to integrate the equation of the curve between x's log of a third and 0. Okay, so if we integrate that equation, we're doing 4e to the x minus 4/3 because we're doing it between the curve and that line. So we want to do the curve, take away the line. Okay, so going back to here, if we integrate 4e to the x, we get 4e to the x. If we integrate 4/3, it's 4x over 3. And we put in the values of 0 and log of a third. So working that through, put in the value of 0, you get 4, and then put in the value of log third, looks like this. So we're just going to try tidy that up a little bit and continue to work that through. Always keeping in mind that we were given what we're trying to get it to, so we're trying to put it into this form here. Okay, so 2 minus log 3 over 3. Okay, so back to where we were, and we end up with this. So trying to take out that factor of 4 here and see what it leaves you with, and then putting it in terms of what the question looked like. So log of a third is the same as log of 3 to the minus 1. That's because a third can be written as 3 to the minus 1. And the minus 1 power can be brought down in front of the log to be a negative there. So that's how that turns into that. And then we're done. Well done if you've made it this far. Share it with friends if you think it's useful. And I will see you next time.